Okay, good day to my supervisor and my moderator, Mr. Wong and Mr. Tan. For evaluating performance of block ciphers in Raspberry Pi 4 is the title of this project, which is a research question on the encryption of the block ciphers to study about the performance of various block cipher that implement to the Raspberry Pi 4. And my name is ANGYEEHANG. Okay. For chapter 1 introduction is for chapter 1 introductions, problem statement and motivations. There is a plenty of block cipher with different programming language that could be found on internet nowadays. These block cipher are specifically designed to perform under any resource constrained environment. This resource constrained environment can be defined in terms of hardware efficiency, power consumption, execution speed, and many other factors. However, not all the library block ciphers are able to manage this factor efficiently, but at least they can absolutely perform their nature at best possible. Okay. Furthermore, there is not a single perfect lightweight block cipher can perform outstandingly well in all circumstances and environment. Besides, most of the block cipher have performance trade-off where you need a faster speed, you will have the higher power consumption and consequently lower hardware efficiency. Hence, in order to manage such problem, when these say constraints are being involved as well, we introduce the implementation lightweight block cipher on Raspberry Pi 4. This implementation is able to provide deeper understanding on the lightweight block ciphers. The extended use of Raspberry Pi through the result and in-depth performance analysis developed in this project. Next is about the project scope and project objective. This project is focused on the performance of various cipher implementation techniques on the Raspberry Pi 4. This is for the project scope. For the project objective, this project is aimed to find out the faster computational speed among all the various block ciphers. Yet, not only the computation speed, but also the key length value, encryption ratio, and security issues of the block ciphers. This will record down into a table that can compare to each other which block cipher has a better performance. The purpose of doing this is to test on the performance that which various block cipher perform without the GPU in Raspberry Pi 4. For the impact, significance, and contributions. The significance for this project is need to consider about the Raspberry Pi 4 processor, because the Raspberry Pi 4 processor is different to our laptop or PC processor. The Raspberry Pi 4 is using the Broadcom BCM2711 quad-core Cortex A72 and so on. So the performance of the processor will be different to the computer to the normal PC. And this project also will contribute to the IT security field about the efficiency of Raspberry Pi 4. The reason of choosing Raspberry Pi as our experiment device is the low power embedded device like Raspberry Pi is requires the high efficiency algorithms. For the chapter 2, literature review. The title is Comparative Analysis Performance, Efficiency, and Security Measures of Block Cipher Algorithms. The author is S. Bhatt, and the paper is come out from 2015. The author is study about three major type of cryptography algorithms, which is transpositions, substitutions, and transposition substitution techniques. And he's saying that there is symmetric keys vs asymmetric keys. The advantage for the symmetric keys is only require low computing power and perform with high speed in the process of encryption. Symmetric will much faster than the asymmetric, and he studied about these few these few block cipher, which is AES, DES, blowfish, and binary tree approach. And for the encryption ratio, he found that the binary tree is the highest among all of them. For the key length, for the key length, the binary tree approach can can be any length depend on the requirement compared to the others. And the DES only allows the 56 bits. But however, for the computation speed, the binary tree approach only got the moderate speed. For the tunability, and for AS and DS, there is no tunability, and for blowfish and binary tree approach, there is for yes for tunability. For security issue, the AS can be attacked by the chosen plain text and know the plain text. For the DES, we can use the brute force attack, but and for the blowfish, we can use the dictionary attack. Binary tree approach as well for the brute force attack. And for next paper is for the next paper title is design and implementation of low area and low power AES encryption hardware core. And this paper is written by Eisenbach, T. Gong, Gunesu T, and Sona. The paper is come out from 2012. They are almost 12 authors to study on this paper, to write down this paper. They are studying about the implementation and performance evaluation of block cipher in a tiny device, which is a ATMLE AVR, a tiny 45 device. They are studying about the block cipher which has AES, DES, DES, XL, High, Idea, Kasumi, Katan, KLEIN, Clean, M Clifton, and so on. They apply this block cipher into the small 8-bit microcontroller with restrict memory, which is the device just now I mentioned, and they are focused in the evaluation, which include the code into the code size, RAM size, cycle count in the encryptions and decryptions, and also the energy consumptions. And this is the result that we can see here. For the block size, the AES got a higher, and the Neokion is the highest. And the key size, they are DES XL is the higher. And for the code size, is the height is the higher. And for the RAM, the idea is use the most RAM in this research. And for the cycle encryption plus key, is the highest is the DESXL here. And descriptions plus key is the also the same. And the energy is this is DSL is the largest. And next, the paper is DS and AS and Blowfish symmetric keys cryptography algorithm simulations based performance analysis, which come out from the author Taku J and Kuma N from in 2011. They are mentioned about their study about this symmetric encryption vs asymmetric encryption. For the symmetric encryptions, the sender need and the receiver will share the secret key, and this secret key will be used for encrypt and decrypt the plain text and ciphertext like the figure shown here. The plain text to the ciphertext through encryption will come out the secret key. They use the secret key to encrypt the plain text to ciphertext. And if you need to decrypt the ciphertext to the plain text, we also need the secret key to decrypt. Okay. For the asymmetric, there is using a two different key to process the encryptions and decryptions. Okay, for the plain text to encrypt, encrypt the ciphertext, which is using the public key to encrypt, and for the ciphertext decrypt to the plain text using the private key. And they also study about the mode of the block cipher, which is ECB, CBC, CFD, and OFD. As we can see, all the result is almost the same. Okay, for the for all the mode is the AS got the higher higher execution time, and the larger the data block size and the higher the execution time lah. We can see all the mode is the same, come out by this author. Okay, for next chapter 3, proposed method and approach. For the methodology, we test on the performance of various block cipher, which is include the AS, DS, 3DS, Blowfish, and CAS. And this is the table that I come up. The AS only allowed the block size is 16 bit or multiple of 16, and the key size of this AS is 16 or 34 or 32. For the code size is about 7.6 byte. And for this all the block cipher we are using the CBC so far. And for DS will the block size is 8 or multiple of 8, which is 16, 32 like that. For the key size is only 8 bytes, and the code size is about 4.7, and the mode also the CBC. For the 3DS, the block size is also the multiple of 8, and the key size is 16 or 24, and the code size is about 5.4 bytes, and the blow is also the same multiple of 8, and the key size is 4 to 56 bytes, which means between the 4 and 56 lah, they can accept for the blowfish for the key. And for the code size is about 4.7. For the cast, the block size also the multiple of 8, and for the key size is 5 to 16, and the code size is 4.8. Okay. As for the AS, the full name is the Advanced Encryption Standard is a symmetric algorithm that can be encrypt the 128 bits block size of data by using 120x, 129 and 3259 bits symmetric key, as I mentioned before. For the blowfish, also a symmetric block cipher that more effective for encryption to and protect the data. And its key length is designed from 32 bits until 448 bits lah. So far, there is no attack is known successful against this algorithm lah. For the DES, also known as data encryption standard, which is using 64 bits of block size 64 bits, and is a symmetric key algorithm that has 56 bit and 8 parity bits, which is total up 64 bits actually. Okay. For the triple DES encryption algorithm, also a symmetric algorithm, and the block size is still 64 bits, and the key size may be 3 times of DES, 2 times of DES, or the same with the DES key size. For the CAS is the 64 bits block length encryption algorithm, and it has 40 to 120x bits of the key length. Okay. This block cipher will be conducted in an embedded device, which is Raspberry Pi 4 Model B with 4 gig RAM, and this tiny device is a series of small single board computers, and it is using a Broadcom BCM 2711 with 1.5 GHz 64 bits quad-core ARM Cortex-A72 processor, which almost equivalent to a mid-end laptop. Besides that, it also contains 2.4 GHz and 5.0 GHz IEEE 820.11 AC wireless and Bluetooth and so on. And we are using the Raspberry OS for this project. For the verification plan, I had come out a standardized plan to verify the test result. For this, block cipher must conduct on the Raspberry Pi 4 Model B device, and all the block cipher must be coded in same language. In example, for this research is Python, and the size of message to encrypt is multiple of 16 bits, or start at 16 bits. 16 bytes, sorry, 16 bytes. Next is the key size length. Some of the block cipher are not necessary to include the key for the encryptions, but to make everything to be standardized, I added the key into the block cipher with 16 bytes size, except the DES only allow me to have 8 bytes instead of 16 bytes. And these block cipher are conduct in the same mode, which is CBC, like just now I mentioned. Besides that, there is also some implementation issue and challenge found in this project. Firstly, I have the most biggest challenge is in this project is to I need to find the suitable code of the block cipher to run in this device, Raspberry Pi 4. And this code almost also must have the same programming language. Therefore, when implement this block cipher on the device would have any argument or on the programming language. Moreover, there is also another issue faced by me, which is I need to read through the coding that have been downloaded from the open source and take time to study how to implement the block cipher. This is because the different programming language will have different of coding structure, and not only about the programming language but also the programmer. The different programmer will have We also have the different of coding style, and this is the timeline 2000 2020 timeline. I start my FYP from in January, defining the evaluation performance of block cipher, and mid of January searching the online research about the title. For the earlier of February, I installed the OS into the Raspberry Pi, which Raspbian. I installed the Raspbian into the Raspberry Pi, and almost the end of the February, I searched for the open source coding and studied until March. For the mid of March, I implement the code and into the device and record the result until the mid of April lah. Okay. For the chapter 4, preliminary works. Okay. The process of primary works is that already done by me is the first stage, which is install choose and install an OS for the Raspberry Pi 4. The OS that chosen for the Raspberry Pi 4, which is the Raspbian OS, and this OS are downloaded from the Raspberry Pi official website. And next step is to write the OS into a SD card that used as Raspberry Pi OS and memory storage. By writing the image file into the SD card, the Balena Ester is one of the software that used for install the OS into the SD card. After the OS been installed into the SD card, then the SD card is plugged into the Raspberry Pi to test on the OS is it work successfully or not. Secondly, for the next step is to get the open source code from the internet and test run on the block ciphers code can be worked or not. With the source file that downloaded, the block cipher is randomly selected out to test and record down the result. For the block cipher that chosen are AES, DES, triple DES, blowfish, and CAS. These block ciphers are coded in the Python language. All are the same lah. And is tested by using 16 bytes block size for the encryptions and decryptions at the first time. As the figures below show, the result of encrypted plain text and decrypted ciphertext for each block cipher lah. For the first one is the blowfish. For the second one is the DES. For the third one is the AES. And for the fourth one is the CAS. And for the last one is the triple DES. And this is the result for how they take how long to encrypt the plain text and decrypt the ciphertext. And this is the result of ciphertext, and this is the result of plain text. Okay, for next is I decided to increase the block size from 16 bytes to 16 times 10 million 16 bytes times 10 million, because this the block cipher will have the big difference between each other, because of the encryption will encrypt such big amount of block size will causes the block cipher run for a while to encrypt the message, and this will help the project to trace which block cipher has the best result, as the figure shown below is all about the result of encryption's block size of 160 megabyte. And for the first one is the CAS cryptography. We can see clearly the message is 10,000 million. And I didn't show out the ciphertext because the ciphertext is too large and the plain text also is too large. And this is the result for the cast, and this is the result for the DES, and third one is the triple DES, and fourth one is the blowfish, also the same the result, and this is the code, and this is the AS. Okay, and this is the result that I come up the table. We can see the triple DES have the higher time to encrypt all the same 160 megabytes. They take the longer time to encrypt lah. For the AS and blowfish is almost the same, and for the DS and CAS is moderate lah the time. Okay. For the chapter 5 conclusions, in conclusion, the cryptography is help to protect the user's data or import info to avoid the data loss or steal by the third party user. However, there is many types of cryptography algorithm out there, but for the cryptography that can perform perfectly in an embedded device is not that easy to find. So that in this paper, I study about the performance evaluation on Raspberry Pi 4 is to find out which encryption algorithm has shown their best performance to us. And this will help the people to implement the cryptography implement in a tiny device in the future. Moreover, the result for the first time to test on the performance, this result performance of encryption, this result the timing is too fast to encrypt 16 bytes long block size, and this cause the data collected by me is very hard to identify which encryption has the faster performance and a better performance compared to others. So that I decided to increase the block size from 16 bytes to 160 megabytes, and this actions may actually causes the encryption algorithm to take more time on encryptions of the plain text. We can see that the blowfish and AS have the better performance compared to other encryption algorithm that implement to Raspberry Pi. Yet this encryption algorithm been applied in CBC mode, which is more common use for the user for now lah. However, the triple DES show the poor performance in this case. For the triple DES, it takes almost 3 times slower than AES and blowfish to encrypt the same size of the block. And we can see just the table just now. We have the blowfish is the lowest one, and AES is also almost the same with the blowfish. And I think that's all. Okay, thank you.